Good morning, children. I am Mrs. Javeria, taking physical science for class 10th. We are into the second session of Unit 9, Electric Current. In our previous session, we had seen what is current, potential difference, and Ohm's law. Today, we'll be seeing what is electric shock. You all might have experienced many a times whenever you are switching on the power supply with your wet hands, or if there are any loose connections, you feel shock. So actually electric shock is a combined effect of potential difference, electric current, and resistance of the human body. It can be experienced when a potential difference exists between one part of the body and another part. And when current flows through human body, it chooses the path which offers low resistance, and the resistance of the body is not uniform throughout. As long as current flows inside the body, the current and resistance of the human body goes on changing inversely. The current passing through our body when we touch a live wire of 240 volts is given to be 0.0024 amperes. When this quantity of current flows through the body, the functioning of organs inside the body gets disturbed. And if the current flows for a longer time, the person in electric shock may be killed also. So, the following table shows us the different effects of electric current on human body. So a current of about 0.001 ampere can be felt, and a current of 0.005 amperes is painful, whereas a current of around 0.01 amperes causes involuntary muscle contractions, and a current of 0.015 causes loss of muscle control, and if a current of 0.07 amperes if through the heart causes serious disruption, probably fatal. If current lasts for more than 1 second, the person is bound to die. What do you see in this given slide? A multimeter. A multimeter is actually an electronic measuring instrument that combines several functions in one unit. If we want to measure current, we connect an ammeter, or if we want to measure the potential difference, we connect a voltmeter. Actually, an ammeter is always connected in series and a voltmeter is connected in parallel to a circuit. If we want to measure all this within an instrument, then we can use a multimeter. Actually, a multimeter has three parts. The display, actually it will be a digital display, the selection knob, which helps us to set the multimeter to different functions, such as to measure current, or to measure voltage, or to measure the resistance. So this is your selection knob. And the ports, that is the third part, which is the ports. Ports are generally labeled as common or ground port, where black test lead is connected. The other is labeled as milliampere volt ohm port, where the red lead is conventionally plugged in. You have a black port and a red port. So most multimeters can measure alternating currents also, but alternating current circuits can be dangerous. So we measure direct current quantities only. Let me tell you one thing, children. Please do not meddle with electrical instruments. Coming to factors affecting the resistance of a material. The resistance of a conductor is defined as the obstruction to the motion of electrons in a conductor. The material which offers resistance to the motion of electrons is called resistor, and the SI unit of resistance is ohm, and this is the symbol of ohm. The various factors affecting the resistance of a material are length of the conductor, area of cross section, nature of the material, and temperature. And in today's session, we'll be dealing with the first two factors: length of the conductor and resistance. Just look at the given circuit, children. A battery, ammeter, key, these are your connecting wires, which are copper wires, are connected in a circuit. All these are connected in series, and we are going to connect a different lengths of the resistances between P and Q. Okay, children. So you collect different iron spokes, that is of different lengths but with same area of cross section, and connect them as shown in this figure. That is, you are going to connect between P and Q. Now when you are just connecting one of the iron spokes, say if it is around 10 centimeters in length, then switch on the key and measure the ammeter reading. Okay, so you are measuring the current flowing through the circuit from the ammeter. Note this. Now change the length of the iron spoke. Say between 15 centimeter iron spoke you are connecting again between P and Q, then a 20 centimeter iron spoke. That is, we are changing the length of the conductor. Okay, so whenever you are changing this, you are going to measure the current flowing through the circuit. We observe that the current, whenever you are increasing the length of the conductor between P and Q, we are increasing, right? So whenever we are increasing the length between P and Q, the current decreases. As a result, the resistance increases. So whenever we are increasing the length, the resistance also increases. Clear? Let's put it out again. Collect iron spokes of different lengths with the same area of cross section. Connect one of the iron spokes, say 10 centimeter length, between P and Q. Measure the value of current using the ammeter connected to the circuit. Repeat this for other lengths of the iron spokes. Note the corresponding values of currents from the ammeter. We see that the current decreases with increase in length of the spoke. Thus, the resistance of each spoke increases with increasing the length of for a constant potential difference. So the resistance of a conductor is directly proportional to its length for a constant potential difference. So this is the symbol of your proportionality. So resistance is directly proportional to L. This is L, children. But this is at constant temperature and constant area of cross section. Now coming to area of cross section and resistance. Now just look at the diagram again. So now in our previous activity, we had taken iron spokes of same area of cross section but of different lengths. Now for resistance and area of cross section, we are going to use conductors of same length but different areas of cross section. Okay, now when you are connecting the iron rod of equal length but different area of cross section between P and Q, and then measuring the current flowing through the circuit from the ammeter, we find that the current flowing through the rod increases with increase in its cross section area. That is, whenever we are increasing the area of cross section of the conductor between P and Q, we see that the current also increases, and hence the resistance of the rod decreases with increase in area of cross section. That is, they are inversely proportional. and hence we can tell that the resistance is inversely proportional to area of cross section. Let us again put this. Collect iron rods of equal length but different areas of cross section. Connect one of the rods between the points P and Q. Note the value of the current using the ammeter connected to the circuit. Repeat this with other rods. We notice that the current flowing through the rod increases with increase in its area of cross section. Hence, the resistance of a rod decreases with increase in area of cross section. The resistance of a conductor is inversely proportional to its area of cross section, R proportional to 1 by A at constant temperature and length of the conductor. Coming to the assignment, what is a multimeter? Second question, what are the factors on which the resistance of a conductor depends? And the third question, what is the SI unit of resistance? Thank you.